And this is the question we are going to do today, and I am clearly told in the question that vector A is able to get obtained when someone says 2b minus 3 over 4q. And the good thing is this: when this has to get obtained, we are always able to get given the value of p, and in this case it's given as a column vector, which is negative 3, 4, and the value of q, which is given as well as a column vector, and this is 16, 4. I don't need to worry so much because I'm given p and q, and it is easier for me to get the value of the vector A. So just come here and say the value of vector A should be equal to 2 into, and I'm going to do what we call substitution. So where there is p, I'm going to put negative 3, 4. And then I will say minus 3 over 4. Then this is able to get multiplied by this q, which is 16, 4. We'll obviously be able to actually come down and get the exact value of this by having vector A being equal to, so 2 times negative 3, that is negative 6, 2 times 4, that is 8. We always open the brackets by picking that value that is actually the coefficient of that vector. We multiply with each and every part of that vector, getting written as a column vector. So we say minus, then negative 3 over 4 multiplied by 16. That is going to be 12. Then 3 over 4 times 4, that is going to be 3. How do we do this? I'll pick my calculator. I'm going to have 3 over 4, or just 0.75, multiplied by 16. It gives me 12. That is right. I'll actually come here and say 3 over 4, and this is actually able to get multiplied by 4. That is 3, as you have seen here. We'll proceed. So you're going to have minus 6 minus 12, that is minus 18. Then 8 minus 3, that is 5. So as a column vector, A is equal to negative 8, 5. And if someone says find the magnitude or the modulus or the length or the size of this vector, which can also get represented as this, you see, this is going to be equal to the square root of, let's look at that. So this is the magnitude, the modulus, the size, the length of this vector. Negative 18 squared, then plus 5 squared. This is the way you can be able to get the magnitude, the modulus, or the length of a vector. We will obviously have this as being equal to the square root of 324 plus 25. So that this one is going to translate into the square root of 349. So you should just get the square root of 349, my students. So let me type, okay, the square root of 349. That is 18.68. So we shall have 18.68 units as the magnitude or the modulus of vector A.